In this lecture, we're going to talk about leveling. So what is leveling? You've heard this word before. Leveling officially is a method of determining the difference in elevation between a series of points. So far we've talked mostly about how to measure horizontal distances. And we've stressed so far that when I say horizontal distance, I mean that it needs to be level. So it's truly a horizontal distance if the elevation at the point where I start is the same as the elevation at the point where I end my measurement. Now, that's not always the case, obviously, and that can't be controlled by us all the time. So we're going to talk about what leveling is and how we're going to approach the idea of measuring distances when the ground is uneven or even, dropping, or there's a higher elevation or bumps, and, terrain is typically filled with different elevation points and whatnot. So it's an extremely important process, and it's critical to any construction process that you do this correctly. So let's talk about some definitions based on this picture right here. Let me get my little highlighter. All right. So if you see this, so the earth is not flat, right? So there's a curve to it. This is some sort of terrain that we're trying to measure. Now, this right here is sea level. We're going to talk about sea level here in a bit. And this is the level line. The difference between so let's say we're measuring this point. So along this point, there's multiple points throughout that are equidistant from from sea level. Now, this vertical line right here, this vertical line is what a plumb bob does. So you stand right here. I should have not used this, but whatever. And you drop your plumb bob, and it goes straight. But really, if you're a few feet from from someone else doing the same thing, it'll look like the lines are parallel and straight. That was not straight. It should have been straight. However, as you get more and more apart, plumb bob lines actually start converging. So let's say if this is the world and there's someone here doing it, it'll be different than someone here and here and here. You see these lines are not parallel, but they'll appear to be vertical wherever you are standing. And truth is, all of these points will converge at, let's say, the center of the earth, center of gravity, right? So the distance between here and here, that measurement is our elevation point. And if we take any elevation point, there's a horizontal line right here, which is tangent at one point to our level line. So let me write down the definitions. Make sure you can copy them down. Give me 1 second. While you do this, so I can drink a little bit of water. My throat's a little... Yeah. Oh, sorry. So again, vertical line is a line parallel to the direction of gravity. Level surface is a surface of constant elevation that is perpendicular to a plumb bob line. Elevation is a vertical distance above or below a reference level surface, typically sea level. And the level line is a curved line in a level surface in which all points have equal elevation. Oh, and I forgot. Horizontal line is a straight line tangent to a level line at a point. So it's important to know these definitions because we're going to be referring to these when we talk about what level is. So if we're going to measure elevation, it is only obvious that we have a reference point. So how do I know how tall this is or how high this is? Well, it's a certain amount of distance from another point. So what is that point? A lot of times what you hear is that a certain point is so many feet or so many miles above sea level. It doesn't have to be sea level. You can always determine like an intermediate point from which you're measuring. So you can say this tree is 30 feet from the ground. Like the top of the tree is 30 feet from the ground, and this ground's not at sea level, and that's okay. However, let's talk about sea level for a second. The definition of sea level is a lot more complicated than you would imagine. For one, the sea level is different in different points of the world. Even within the United States, the sea level on the East Coast is not the same as sea level on the West Coast. And one of the main complications is we have tides. So the tide goes in, the tide goes out, and that changes sea level. So officially, sea level is now determined by the averaging of the elevation changes over many years, assuming that all tides and currents were eliminated. So an average of the average over many, many years was what was used to determine sea level. Now, if you are using sea level as your reference point, there are different, they're called datums. These are kind of the official number. And I forget what NAVD stands for, but there was one in the 20s and another one was determined in the 70s, and then it was updated in the 90s. And right now we use NAVD 88, but different parts of the world use different ones for sea level. What's important here is that you know that sea level does not mean the same thing everywhere, and that you need to know what datum you're using to know exactly how to calculate your elevation or what your elevation really means. So you have to be specific. This is important. We're not going to worry about this too much in this class, but it is one of those things that whether you become a surveyor or whether you never do surveying again, you need to know that this is an important thing. All right. Okay, so that brings me to a discussion about something called benchmarks. So it would be hard to just base every single measurement from sea level. But another way to do elevation changes is to find a benchmark. Now, a benchmark is a concrete or brass disc located in a specific monument, and by monument I don't mean like a statue. It can be a hill or a mountain or a rock or something, where the precise elevation is known and was measured and is kept up with by the NGS and the U.S. Geological Survey. So they try usually to find, and they nail these to the ground, find places where these cannot be easily removed or moved by geological features. So obviously there wouldn't be like a benchmark right next to water, to a body of water that could, shift the ground and make it be lower or higher than it should be. It's probably also not somewhere where it can be vandalized very easily. And if you travel across the United States, you may find these in random places, but you also see some really cool ones in very beautiful places. For example, I know that there's one of these at the top of Enchanted Rock what town is it in? I don't know what official town it's in, but if you go towards like Fredericksburg, there's this beautiful place. I highly recommend visiting. And at the top of, the round rock, kind of this big hill, is one of these. So surveyors who work for the U.S. Geological Survey or the NGS make sure every once in a while, periodically, that these are having been messed with. So if you know this elevation will be given to you in terms of sea level, but once you know that, let's say we found this one and it was at 535 feet above sea level, then you can use that as like an intermediate point to determine other elevations around you. Okay, so let's talk about leveling methods. So there are three main methods used: trigonometric, barometric, and spirit. So trigonometric we've talked about before. It's when you're able to measure distances and angles. Then you can use trigonometry and your triangles to figure out what's either the horizontal distance or the slope or the elevation change. So if you have, something, let's see right there. Nope, but I don't want a highlighter. I want a pen. There we go. So if you have this, and this is supposed to be straight. If you know this distance and you know this distance, you can determine this one. Or maybe you know this distance and you know this angle and you can determine that. And this, if this is 525 feet and you determine that this is 10.3, then here you're at 535.3 or something. Sorry about the handwriting. Anyway, however, due to the curvature of the Earth, this only works up until distances of 800 to 1,000 feet. We're going to talk about what the curvature of the Earth does to our measurements, because this line right here is not necessarily straight forever. As you get longer and longer, it actually starts becoming a curve. So we're going to talk about corrections for the curvature of the Earth. And you've probably seen this before, but your triangle, your difference in elevation, your slope, your horizontal distance, all that good stuff. You should be able to figure this out. The next leveling method is called barometric leveling. It is determining the elevation by measuring changes in the air pressure. So there are these devices called mercurial barometers, but they're fragile and impractical for surveyors. And there's these other ones called altimeters, which are used more by surveyors because they're lighter, but they are less precise. Now, the book doesn't go in a lot of detail about barometric leveling. I'm gonna guess that this is expensive material and that this is really not what surveyors do most of the time. This is kind of like something you would do like preliminary study, or if you want a little precision, you can do this, but maybe expensive. And truth be told, now there's equipment like total stations and GPS that can do a lot of this stuff for you. But in the case of what we're talking about now, we're going to talk most of the time, for the rest of the class at least, or the rest of the lecture, about spirit leveling, which is also known as direct leveling, where this is when you have vertical distances that are measured in relation to a horizontal line, and the values can be used to compute the differences in elevation. So this is what works, and for the purpose of spirit leveling, we're going to talk about equipment, but on the most part, at least in this class, we're going to be using an automatic level or a theodolite, but this is what automatic levels are for. You have your instrument, and you have your backside and your foresight, and just by reading our range rods, sorry, and determining what these points are, you can do a little bit of math and figure out what the elevation is at different points. And we're going to talk more about that over in the next video.